Hello, this is Clayton Balmus, and I'm your teacher here today with our audio classroom here at SynMax University, available at synmaxperformancelubricants.com. Today, we're in part two of our series, which is a very important education here. It's called Heat Vapor Bubbles, Foaming, and Cavitation Effects on Performance. I like this picture. I took this here at Road America. That's my picture. But anyway. So let's continue on and let's learn something here today. One of the things we have to look at is that air bubble compressibility creates fluid problems. Here's the situation. When we're trying to have heat transfer, vapor bubbles are created as an important and natural part of the coolant system and heat transfer process. The problem is that historically air bubbles within the system have 10 times the compressibility as compared to the fluid. Now this applies whether it's water or oil. The solution is with an advanced chemistry, efficiently and effectively, it needs to disperse these bubbles with chemistry science performance before they get out of process control, and then you're going to have foaming and boiling. So you got to nail it right at the surface before it gets overdone. All right? Now, we have to mention that chemistry is not going to overcome mechanical or engineering issues. One of the important things in the science of water chemistry and coolant chemistry is to understand what's called nucleate, which is hot spot area, and film boil, which is the entire surface. Now, to to demonstrate what this is, before I get into this, is like if you were boiling water, okay, and you look at you're making some pasta, right? The hot spot would be right where the flame is at, okay? That's where you start seeing the boiling right there. And then all of a sudden, then it goes to a simmer, then that's a film boil. Now that same situation happens upon the surfaces of your vehicle, of your engine. That is why there's going to be different hot and cold points within the coolant system. But let's go through into the more greater definition here. Nucleic boiling to film boil. Nucleate is localized surface hotspots. Then over time, the nucleic vapor bubbles spread over the entire surface, creating a film boil. Now that's just natural. Now film boil is a continuous thin layer which covers the heating surface area and keeps the cooler liquid from contacting the hotter surface. This insulating effect of the film boiling vapor reduces the rate of the heat transfer and coolant fluid coefficient. As the temperature difference increases, the vapor film becomes thicker and thicker, eventually reaching maximum thickness or a full boil. Now this is important. If the water metal surface tension is not reduced and controlled, the small vapor bubbles, hydrogen heat and water vapor bubbles emitting from the metal, will increase to a surface film boil, and that is what you don't. It's out of control. Now, one of the other things that we have is aluminum and other metals. When they make the metal, it traps in hydrogen, okay? And when these metal alloys decompose, either from electrical situations, because aluminum is an electrical metal, or heat process, all right, the hydrogen is released. Now that happens a little bit, but it's part of the process, and it's called a physical vapor uh, deposition. Again, heat transfer and vapor bubbles. These unremoved small vapor bubbles on the metal surface creates and forms an insulating layer which impedes and stops the heat transfer process. Now, the release of these bubbles from the localized hot temperature area or boiling region, in other words, the nucleic spot, is important to improve increased heat transfer performance capability with the right chemistry, 15 to 20%. Now, one of the answers is the treatment should have an advanced non-metal water chemical technology to coat the metal surface, reduce the tension of the bubbles and the friction of the water. The water chemistry surface tension can reduce this in half with the right chemistry. And it needs to be able to coat the surface without causing foaming or cavitations. Now, so then we have what's called an anti-foam control. All right? So what we have to realize is that we have hot metal. It's creating the bubbles. The bubbles have to be dispersed. Now, we can only do so much with water or the chemistry that's available, unless you have like those SynMax water cooler advanced water chemistry science. Them's a lot of words, Clayton. I know they are, but it's a choice for a better chemical material that will help the bubbles when they come out to disperse into the water easier so that they can stay small. When they get thick, it's not a good thing. When they're small, we want to be able to grab them, disperse them in the water, and get rid of it. And part of that involves a special heat transfer chemistry. Now, this is part of the foaming. Now, anti-foam control is important since the entranced air will cause internal fluid compression and then erosion, and then it's going to create foam, right? So it's not like dropping a pill in there. This is a whole chemistry science that we got to do. You see, quality anti-foam control produces a complete fluid environment, which includes reducing fluid friction, therefore improving the fluid's hydrodynamic ability to flow freely and easier without obstruction or disruption or cavitations, as we explained before. Okay? What's obstruction or disruption? Rust, corrosion. Okay? So if you don't have the rust and you don't have the corrosion and you have a clean metal surface, life is much easier. And that is where improved chemical science comes in. You see, the treatment should have an excellent anti-foam performance because it prevents the foaming process through its advanced and effective surface chemical film coating that will create and encourage smaller vapor bubble formations, providing less violent bubble collapse and dispersing the vapor bubbles evenly within the coolant. Say, Clayton, you said that twice. I was trying to drive a point. Cavitation protection. You see, within the localized area, nucleate or film boiling, within the cylinder head and cylinder walls, especially near the top of the piston compression area. All right? Now, more than top of the piston, it's the exhaust side of the cylinder wall and the top side where the cylinder head is. This forms aggressive vapor bubbles, and when they collapse, when they come in contact with cooler liquids, the chemistry helps this. But the problem here is if the vapor bubble, you don't have a process for it to collapse, it's called a cavitation. It's just going to sit there and sit there and sit there and finally go bang. And it's going to create a tremendous shock wave. And when it goes boom, and when it goes bang, it's going to remove the inhibitor film from the aluminum surface. And if you don't have a film to form quickly, which is like the chemistry that we have in the water cooler, it will cause an erosion of the aluminum. Cavitation erosion of the removed aluminum creates a decomposition, contaminants, which then will stay within the system and really hurt the heat transfer process. Again, advanced chemical technology provides premium protection from cavitation erosion within the cylinder head and cylinder wall surface areas by properly coating and increasing the heat transfer process and keeping them bubbles a happy camper. Now, in NASCAR, they increase the pressure with a special pressurized system, and what they do is this increased amount of pressure keeps the vapor bubbles against the wall. See, they don't try to solve the issue with chemistry; they try to solve it with engineering, which does have some success. But unless you've got an extra $1,500 to $2,000 in your pocket and a $3,500 radiator, etc., and you only can deal with what you have in your late model or whatever racing or automotive or commercial application, we need to address this bubble uh, formation on the surface by dispersing it properly with chemical science technology. So then our next presentation, we're going to talk about water and system cleanliness. You're going to love that one. Okay. So in summary, for anti-foam and surface protection, you require a quality, advanced science chemistry found within the water cooler products. Now, everything listed here is what the water cooler chemistry will do. Now, here we have a 16-ounce bottle that will go into an a 2 or 3 gallon system. Again, you need to use the purified water, and this will help improve the nucleic and film boil performance, reduce cylinder head and overall temperatures, reduce contaminations of the coolant system, and everything else listed here. Now, the premix is a simple pour and go system. It is the exact chemical concentrate with the purified water combination. Now, in racing, it's a 100% direct pour in. In all weather antifreeze conditions, you have 1 gallon of water cooler, 1 gallon of glycol or whatever you're using, and you won't need any other system treatment. And this is great for diesel trucks, automotive, standard gasoline, biofuel conditions. Furthermore, it has tremendous performance within the intercooler application for the turbo and supercharger intercooler fluid requirements. Here we are at the end of our bubbles, foaming, and cavitation effect and performance presentation. In summary, we have to make sure those surfaces are clean and we use the most advanced water chemistry science available for performance and repeatability and efficiency. And that's available with the water cooler products and purified water. So we encourage you to listen to our other presentations that we have on the coolant system and videos. So this is Clayton Balmas here at SynMax University with SynMax Performance Lubricants.com. We look forward to seeing you at our other sessions. And we wanted to thank you for our time together. For technical, test, and brochure information on how the aerospace advantage for motorsports can work with your race team or other commercial requirements, please visit us at synmaxperformancelubricants.com.